Okay, this is a video tutorial for lesson 2.1. This is our new module, and in this one, we're going to be looking at finding slope. Strongly recommend you go on YouTube, look for the Adventures of Slope Dude. It'll tell you about the 4 different types of slope in a very entertaining way. So the 4 different types of slope are positive, as we go from bottom left to top right, negative, as we go from top left to bottom right, zero slope as we go across, because basically there is no slope there. Slope, you kind of think of how steep something is. So if you have something that's flat, then literally there is no slope there. And the last one, the special one, is undefined slope. A student wants to remind me of this one for undefined. It starts with a U, and so does up, and it ends in a D, which is down, because this line goes straight up and down. And in terms of when we calculate in slope here, there's a few little notes here. If we ever do 0 divided by anything, that always gives us 0, which is this one here. And if we ever try and divide by 0, sometimes you get an error. If you use the Desmos calculator, it does actually say undefined, which is useful because that's actually what we're going to find here. So certainly recognizing the pictures for what is a positive slope and a negative slope can be particularly useful, particularly on questions like this. If you see 2 answers that are perhaps negative, you can ignore those straight away, knowing that this is positive slope. Now, the specific slope formula is y2 minus y1 over x2 minus x1. And it says we're going to find the slope between these 2 points here. So as we're doing the question, it's important that we write the question out. And the reason we want to write the question out is because in a second, we're going to label these coordinates. So what we're doing is we're just substituting these numbers into this formula here. So I'm going to label the first coordinates, obviously we know are x coordinates. And we know that the second coordinates are y coordinates, and we looked at that in the previous unit. So as this is the first coordinate, we call this one x1, y1. And as it's the second coordinate, we call this x2, y2. Now, as I'm substituting into this formula here, I just put my fraction line in straight away here. So my y2 value is 5. And then it says subtract y1. So y1 you can see here is 2. And we just do that for each of the coordinates. Now, you might think that, well, I can tell this as y1 here without writing this down. For whatever reason, people that tend to skip this stage here do tend to, for some reason, misline these up when they're substituting in. So just take the time to write the coordinates out and label them to make sure you don't make that type of mistake. On the bottom left here, we have x2, which I can see is negative 10. And subtract x1, which it says is 5. And then you can just use your calculator to work out exactly what this is. In fact, if you type this in all in one go, it will actually give you an answer. And if you click on that little fraction button on Desmos, it will actually go ahead and simplify this fraction for you as well. If you're doing it by hand, the top is 3 and the bottom is negative 15. And if you check that one to see if it simplifies, you would find out that actually it does simplify. And the answer would be negative 1/5. Now, we can also do these by counting squares as well. So if we have a picture, and these are the 2 points in the original question, we can also work this out by using the formula rise over run. So what we do is we look at the triangle here. When we're doing rise over run, we can start from the left-handmost point, and we have to get to this point by either going up or down, and then going to the right. So for this point here, I would have to count downwards. So counting my squares here, I go down 1, 2, 3, and then I go across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So negative 3 over 15, which also simplifies to that negative 1 over 5 here as well. And you can actually also just do small parts as well. So I could actually just go from here to here. I can see this goes through a corner of a square. I go down 1, and then I go across 1, 2, 3, 4, 5. Just so you get an understanding of what actually a slope of negative 1/5 means. So the top number tells you how many you go up or down. If it's positive, you'd go up. And if it's negative, like this one is, you go down. But we always count to the right when we do these questions. So never start from this side. Otherwise, when you go across, you have to count to the left. So that's something that's really important for these questions as well. Same sort of thing. So I got negative 7, 8. So I'm going to write out the question first because I want to label the coordinates. Negative 7, negative 4. I'm going to label my x1 and y1. And hopefully you'll be able to do this a little neater than what I'm doing right now, because I'm just using my mouse pad. So we're going to substitute into this formula. So y2, I can see is negative 4. subtract y1, which is 8, and I'm going to divide by x2, which is -7, take away x1, which is also -7. And you can just type this straight in one go. If you work them out separately, you would end up with -12 over 0. And that was one of the ones that was mentioned over here earlier. If the 0 is on the bottom when you divide, you'll actually have something that is undefined. So hopefully if you actually check this, if you check this on Desmos, it should actually say undefined for -12 over 0. If you just use a standard calculator, it'll probably say error, and you have to know that that actually means undefined. Now, if you actually type in the two coordinates for this, the two coordinates here, whoops, I'm actually just a little too zoomed in right now. Let me just zoom out for a second. There we go. We can kind of see this a little bit. You can see that the points are directly above each other. So by plotting the two coordinates, sometimes you get a good idea of whether something is undefined like this, or if it is that 0 slope. So certainly worth actually typing those in, just so you can check. Next question, 3, 9, and -2, 9. And I can put the parentheses around, and then I'm going to label them again. So x1 and y1. And for this one, x2 and y2. And y2 is 9. Subtract y1, which is also 9. All divided by x2 minus x1, so -2 minus 3. And if we type this all in one go into Desmos, it will actually just say it's 0. If you split it into 2, you would get 0 over -5. And 0 divided by any number is just going to be 0. Now, as I go ahead and look at the picture for this one, you can actually see, once I've typed in the two coordinates, you can see that this is actually a 0 slope from that picture earlier. So another good way just to confirm actually exactly when it's 0 and undefined. Now, one other way we can actually check this, and we'll probably talk about this in a different lesson, is the two words hoy and vux. And these are really useful for helping us to figure out what slopes are as well. Now, on this question here, I noticed that the x values are actually the same here. And this will always happen on this type of question here. So the word vux, what it stands for is if we have a vertical line, that's the V, the slope is undefined, that's the U. When we do equations of lines later, we'll know that the equation begins with an x. So this is really useful. Once I see that the x values are the same, I can think of the word vux and I can pick out the word vertical. Now, when I go to this question here, I'm using the other word, I'm going to use the word hoy. So when I see a picture like this and I see this horizontal line here, then this is actually not an O in this case, it's actually a 0. So the horizontal line gives you a slope of 0. And when we start to write equations for these lines, then we'll just put y equals a number. And specifically for this one, it would be y equals 9. You can see actually the y coordinates here are 9. And on this one here, you can actually see the x coordinates are -7. So that'll be something that'll be useful for later. Let's try this one here. Notice this time the x values and the y values are different. So this is not going to be one of those special ones. This will actually give us some sort of answer. So -4,6, 0, 8. So I'm just following that same procedure each time. I'm typing in x1 and y1, and I'm typing in x2 and y2. So y2 minus y1, so 8 minus 6. And on the bottom, I got x2 minus x1, so 0. Take away -4. And if you type it in one go, it will give you the answer. If you split it up into 2, we'd have 2 over 4, and that will actually simplify to 1 over 2. Now, as I look at the picture for this, the reason I think it's useful to plot the coordinates first is you can see from this line, from that picture we had earlier, that looks like this line here, which is positive slope. So if this was a multiple choice test, certainly any answers that give you negative slope are something that you could ignore for this question, and then you can just focus on the positive slope. If we're counting out the squares here, remember we're going to start at the left. Now this time I am going to go up first because I can't go down or else I'm moving away from the graph. So I would go up 2 squares, and then I would go right 4 squares. And there's that answer that I had a second ago. There's that 2 over 4. And if you simplify that, you do actually get 1 over 2. Notice if you go up 1 and across 2, you do get back to that line as well. Or if you go up 1 and across 2 from there, you get back to the line. So it doesn't matter where you really count the slope from on the line. You just want to kind of make sure it goes through a corner of a square like this. You don't want to start from here. It goes through the vertical line, but there's no horizontal line here. But if you start here, you can see that it goes through the vertical and it goes through the horizontal. So that's kind of important when we're doing these. We also use the letter M for slope as well. And here is that rise over run thing that I was talking about in the earlier questions. So you can see you go up, and then the run is always to the right. No matter where you do this from, you can see that it goes up 4 and then across 3. So we'd have a slope of 4/3. What is the slope of this line? Now, we've got several points. I'm just going to use this point and this point. So I'm going to start from the one on the left. I can see that I go down 1, 2, 3, and then I can go across 1. Now, to show I go across down 3, I would put -3, and then show I went across 1, I would put 1. Now, if we type this into Desmos or just simplify this, you'll find actually the answer is just -3. And then we can fill that answer in here. This constant rate of change just means that on the question like this, wherever we work from, we're always going to get the answer -3. So I could go down 3 here and across 1. I could also actually go from the first point to the last point. I could go down 6, which would be -6, and then across 2 squares. And -6 divided by 2 is also -3. So we get the same answer wherever we actually work this question. Find the slope of the line from graph 1. I'm not sure why we actually have a graph for that one. Well, we can see the graph perfectly well here, so I'm just going to move straight on to slide 15. Find the slope for this one. So I'm starting from the one on the left. I go up 1, 2, 3, 4, 5, 6, 7, and keep going until you get level with the graph, with the other dot, sorry, and then count how many across. And you can see this is 3. So I went up 7, so that's +7. And then I went to the right 3, so the answer would just be 7/3. Doesn't simplify, but you can check in Desmos if you're not sure. Perhaps the other way for doing this question is you can physically write down what coordinates these are and then work the question how we worked it previously. So this coordinate here is -1, -4. 1, -4, and this coordinate over here is 4, 3, and then you could use that formula if you needed to. But if you have a picture, it's much easier just to count the squares. This time here, I can see I'm going up 1, 2, 3, and I'm going to stop once I'm level with the dot, then across 1, 2, 3, 4, 5, 6. So 3/6. Check on Desmos, it simplifies to 1/2. And actually, if you look on this picture here, and I'm going to erase my original lines just for a second, hopefully you can see if you went up 1 and then across 2, you would actually get back to the line as well. So that's another reason why it's 1/2. And wherever you do this, you can go up 1 and across 2 just to get back to the answer. Drag point B so that the line has a slope of 5. Now, kind of one thing we need to pay attention to is that one of those earlier questions that we had here, which was this. When we have a single number, what was important was we actually went across 1 square. So whenever we have a slope of 1 number, often we'll write it over 1 to remind us how many squares we rise and then how many squares we run. So going back to this question, a slope of 5, think of it as 5/1. So that means I go up 1, 2, 3, 4, 5. And then across 1. So if I move point B to here, you can see that that does give me the correct answer. If I put it anywhere else, you can see that I get the wrong answer. So really this is just counting squares, but it's knowing how to count squares. And this time on a slope of -1/4. So -1 means I go down 1, and then the 4 means I go across 1, 2, 3, and across, of course, I mean right for run. And then if you can see once again, that is good. Now, these might be a little bit small for us to see, and I'm not sure that all of these actually match. Looks like we have more graphs here than we actually have equations. So very small dots here. This is going to be very difficult to do. Up 1, 2, and then across 1, 2, 3. So this has a slope of 2/3, but I don't actually have that as one of my answers. So I'm going to ignore that one. This one here, I can see I go down 5, down 6. And then I go across 10. Now, -6/10, if you simplify, is -3/5. So I'm going to go ahead and I'm going to join those two together because that one looks good. And what do we got here? This one goes up 5, 6, 7, 8. Actually, if I remember, yeah, there you go. You can actually click on the picture and it's much easier. Up 5, 6, 7, 8, and then across 1, 2, 3, 4. 8 divided by 4 is 2. So let's have a look if one of them's 2. That one is 2. So I'm going to join those two together as well. Oops. This one here, I go down 1, 2, 3, 4, 5, 6, 7, 8, and then across 1, 2, 3, 4. So -8 divided by 4 is -2. And I don't think I have that as an answer, so I'm going to ignore that one as well. Oops, I didn't really mean to join those together, but let me move that over the way. Oops. And there. Now, actually, as I'm trying to do this, I can actually use some shortcuts. Notice the line here you can see is positive and this is positive. Clearly, this one's going downward, so this is negative. So I think this might be -1/2. So let me just check. Down 2 and across 4, and -2/4 is indeed -1/2, or even down 1 and across 2, you can see brings you back to the line. So those two certainly match up. 5/3. I'm actually wondering if that's this one here and if I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then across 1, 2, 3, 4, 5, 6. And 10/6 is 5/3. So that one would match up. And I think that's good. I don't think there's anything to check the answers for this one. Nope. And so I have the same slide twice at the end. Looks like I made a slight mistake there. That should do it for this one on slope. So the two things we learned today are we want you to be able to find the slope by using the formula. And we also want you to find the slope by looking at the graph and counting out the squares. And if I just go back quickly to the start, try and learn these 4 different types of slope. The one that's positive, negative, 0, and undefined. And that will also be very helpful when we're trying to do questions.